Hello everyone and welcome to our channel. Multiplication is rotation. Well, wondering what I'm talking about? I'm talking about the concept of the complex number, which says that for vector in the complex plane. So I'm taking a vector OP having the complex number Z. When you multiply this vector of the complex plane with a complex number in the exponential form e power iota theta, then this vector OP gets rotated and the new vector turns out to be Z e power iota theta. So this vector gets rotated by an angle of theta in the counterclockwise sense. So this concept of rotation, I'm going to use today in this video to solve the very classic Gamow's puzzle. Let's see what is that and use this elegant method to simplify or to identify where the treasure is hidden. So let's start with the question. What exactly the question says, let us see. The question says that go to the gallows. Well, this information is being provided for an island where the treasure is hidden. And on the island, there are two trees. One is pine tree, the other one is the oak tree, and a gallows is there. So to identify where the treasure is hidden, we have to read this information. So let's start with go to the gallows and walk directly to the pine tree, counting your spaces as you do. Once there, turn 90 degrees to the left and walk same number of paces. So you have to go first to the pine tree and follow this instruction. Put a stake in the ground at that point. Go back to the gallows and walk to the oak tree, counting your paces as you go and turn 90 degrees. But now you have to turn right this time and walk out from the tree the same number of paces. Put a stake in the ground at this point also. The treasure is buried exactly halfway between the stakes. Well, how we are going to utilize this information to solve the question and especially using the concept of complex number. So let's start with the question. I'm going to make first of all the complex plane. So here is the imaginary axis and the real axis. And without loss of generality, I'm just assuming that the middle point of two trees is the origin. The middle point of two trees is the origin. Middle point of two trees as origin means I'm just assuming that let this be the pine tree T1 and let this be the oak tree T2. And somewhere we have the position of gallows as well. In the question, the relative position of gallows with respect to tree is not given. So I'm assuming that the gallows has the complex number a plus iota b. Okay, one more thing, T1, I can assume that this unit is 1. So taking it as 1, 0. T2 I can write as minus 1, 0 similarly. And since A and B are unknown, there is no problem with the position vector or the complex number that we have taken corresponding to G. Now let us start following the instructions. What we have to do to identify the exact position where the treasure is hidden. We have to start moving from gallows towards the first tree, that is the pine tree. Fine, so we are moving toward the first tree, the T1, the pine tree. And from here, you have to take a left turn 90 degrees and walk the equal number of steps. So after walking the equal number of steps, you will reach here. Put a stake over here. So we are putting a stake over here. Now going back to the gallows and following the same thing for the second tree. So again, from gallows, we have to move towards the second tree, T2, the oak tree. So move towards the oak tree. From T2, the oak tree, you have to take a right turn and move equal number of steps. So I'm moving 90 degrees right and taking equal number of steps. You will reach this position, and at this position, again, you have to put a stake. So I'm going to put a stake over here as well. So this is the stake. I'm just naming these two stakes as S1 and S2. The question says that the treasure is buried halfway between these two stakes. So, okay, let's find out, or let's draw the position of that treasure. So I'm joining S1 and S2. I just need to find out the middle point of S1, S2, where we are going to find out the treasure. But how we are going to find it out? So let's start with the calculation part. Using the rotation concept, we are going to solve the question. I'm going to start with, first of all, finding the complex number corresponding to S1. What I'm going to do is, as you can see that we have the vector T1S1. We have the vector T1S1, which is obtained by rotating the vector T1G in the clockwise sense by an angle of pi by 2. So because the direction is pi by 2, you can notice the negative sign in the exponential over here. Now T1S1 gives me T1G. What is T1G? T1G is nothing but a minus 1 plus iota b multiplied by e power minus iota pi by 2. That is minus iota. Or you can say that T1S1 actually gives me minus b minus, or in fact it will become minus into minus iota square as plus b minus iota into a minus 1. Okay, but this is T1S1 vector. What you need is the possession vector, or you can say the complex number corresponding to S1. So that also we can find here. S1 turns out to be b plus 1, because we know the possession vector for T1, minus iota a minus 1. So now we have the possession vector corresponding to S1. Let us find out the complex number corresponding to the point S2. For that, the similar approach, here I can write that the vector T2S2 is obtained when you rotate the vector T2G, but in the counterclockwise direction by an angle of pi by 2. Let's complete the calculation part. T2, yes, we know the possession vector for T2. S2 के लिए we are solving it. What about T2G? So T2G को you can write a plus 1 plus iota b and multiplied by e power iota pi by 2. T2S2 turns out to be minus b plus iota times a plus 1. But this is T2S2 vector. So let's find out S2. S2 becomes minus b minus 1 plus iota a plus 1. So now we have the possession vector or the complex number corresponding to the two stakes S1 and S2. What you need to find out here is just the middle point of S1, S2. So let's write that down and find out the position where we have to bury to get the treasure. What you need to do is just find out the middle point of S1 and S2 by 2. So adding the two complex numbers together and dividing it by 2 gives me iota. So B got cancelled, 1 got cancelled, A got cancelled, and we are just left out with iota over here. Iota means here is the position. This is the point where you have to dig to get the treasure. You can also observe one thing here. The answer that we are getting is totally independent of A and B. Or we can say that it is totally irrelevant where the gallows is actually situated. What you have to just do is go to the T1 and T2 trees, just draw its perpendicular bisector and see the distance is 1 unit from the perpendicular bisector, or you can say from the origin. So this is the point where we are going to find out the treasure. Using the same approach, you can also solve another question, which is a little more sophisticated. But now I'm going to show you another question of the similar type, a question which is framed on the similar pattern. I would like all of you to just solve this question and wait for the next videos to come to find the solution for the same. I hope you enjoyed today's video. Thank you for watching. Bye-bye for now.